Hi everyone, this is just a quick video showing you the nuts and bolts of how to do a hypothesis test in Excel. This is going to be a t-test for the two samples assuming unequal variances. So I have here my productivity data from the ABS again. I have labour productivity and I've got capital productivity. So what I'm going to do to start with is say, are these two means equal? I'm going to assume we have unequal variances. There's a couple of different ways to do this, but that's how I'm going to do it this time. Again, this is time series data which is trending. This isn't a hypothesis test that makes a lot of practical sense, but it's a useful data set. So we'll just go through the nuts and bolts here. So I'm going to go to Tools and Data Analysis. I'm going to take a two sample assuming unequal variances. I'm using a t-test here because I don't know what the population standard deviation is, and I have quite a low sample size of 21. Okay, so I press OK. My variable 1 range is B2 down to B23. This is label productivity. Variable 2 range is C2 down to C23. This is capital productivity, and I've clicked the labels one. I'm hypothesizing that there's no difference between the two means. If I wanted to hypothesize that, say, capital productivity was 20 units higher than labor productivity over this series, then I might put in 20 there. That's what you do there. So if you're hypothesizing no difference, then put in a 0. I'm using an alpha level 0.05, and I'm just going to plonk my data down here in the bottom here so I can see it on this one sheet. So let's go. That's fine. Okay. So what we can see here is that the mean of labour productivity is 83 thereabouts, whereas capital productivity is 122. And we'll talk a little bit about that in next videos about why that might be. There's a fairly large gap between the variances here, so I think I was pretty justified. That's a bit of a rough and ready measure, but we'll go with that. They do appear to be unequal. There are tests for that. We're not going to go over that just now. There are 21 observations in each group. I'm hypothesizing a mean difference of 0. That gives me a degree of freedom of 37, and the t-statistic that's being calculated is -10. So we've got a p-value here for one-tailed test if we're just going to say that labour productivity was greater than capital productivity, for example. And we've got a p-value here for a two-tailed test, which is if we're going to say that that there's just a difference, so that we could be on either tail. Now here we've got a negative here, so what we're actually saying is that labour productivity minus capital productivity is less than 0. Because we can see here that capital productivity is clearly bigger than labour productivity. Okay, now let's fix these up for if we wanted to take this out of Excel to talk to people about them. Never hand anybody with anything with 7 decimal places. Okay, so that's a lot neater. So I would reject the null hypothesis, whether it's a 1 or a 2-tailed test, and say that the two productivity indexes do not have equal means over this sample. Okay, next thing, regression.